We'll continue looking at problems where we have 2 points and we're trying to solve for the linear equation. Now we're going to look at 2 points both on the axes, either the x-axis or the y-axis or both the x and y-axis. And graphically, it should be pretty easy to see what we're going to solve. But a lot of times you're going to be asked to solve this mathematically. If you have in the back of your mind what happens graphically, I think it will help you conceptualize what's happening or what kind of equation you should get. Right? So here we have 2 points on the y-axis. So hopefully you can visualize what line this will look like. So our points, what will they be specified as? Both of them, we're going to have a value of 0 for x because it's going to lie on the y-axis, which sits on the point x equals 0, right? It's kind of arbitrary what points we choose for y, right? I choose 5 or 2, it doesn't really matter. I could pick any number. It's going to show up, the line that connects them is going to be the same. Now, I'm trying to determine y equals mx plus b, so I need the slope and I need the y-intercept. This one's a little bit odd, but we'll see how it plays out when we try to plug it into the equations. So typically I would use rise over run, and that's just a delta y and delta over delta x. So let's see what this looks like for us. If I plug in the difference in y, y2 is 2, y1 is 5, so 2 minus 5, I'll get a numerator of -3. Now divide that by the difference in the x location, 0, 0. 0 minus 0 is 0. Something divided by 0 is undefined or infinite. In this case, this means the slope is infinite, right? What does that physically mean? Well, you know what the slope looks like when x equals 1. You make it steeper and steeper, it looks like this, right? If you can see my cursor. And if you make it super steep, then we'll call that infinite, right? You're increasing it to a very, very high number. That's kind of useless for us, but anytime we have a vertical line, we say that the slope is infinite. Well, how does that infinity sign show up in this equation? It doesn't. We don't use this equation if that's the case. What do we do instead? Well, if I try to find the y-intercept, remember the y-intercept is when the line intersects the y-axis. Well, if I draw a line connecting these 2 points and just extend it on both sides, then it's going to intersect at every single point. Well, that's kind of hard to write a single value for infinite numbers. So when we have a vertical line, we don't use this form to write a linear equation. Instead, we just define at what x location we have it, right? In this case, if it's on the axis, we say x equals 0. If instead the points were 1, 5 and 1, 2, right? Then your vertical line will be at x equals 1 and so forth. So whenever you see a vertical line, then you know that you're going to define that line with x equals something. When you have 2 points on the y-axis, you know you're going to define that as x equals 0, right? Okay, so let's take a look at another example. And in this case, we're going to have 2 points. Instead of on the y-axis, we're going to have them on the x-axis. So I just swapped my x and y components. So I have 2, 0 and 5, 0 instead of 0, 5 and 0, 2. Okay, so for this one, we can solve for a slope, and I can solve for y-intercept. Quickly click pause, see if you can solve for this one. So we solve for slope, rise over run. Maybe you can estimate or guess, or maybe you know what that value is, because this is going to be a horizontal line. Rise over run. Is there a rise? No, there's no rise, right? Y2 and y2 and y1 are the same. They're both 0. So that's going to give me a numerator of 0. x2 minus x1, that's going to be 5 minus 2. Doesn't matter. This slope is still going to be 0. When we have a vertical line, our slope is infinite. When we have a horizontal line, our slope is going to be equal to 0. Okay, what's our y-intercept? Where do we cross the y-axis? We cross it right along the origin. So that means b is equal to 0. We can see that that's where we're going to cross if we extend it here. So what is my equation? Well, my points are along the x-axis, so my equation is y equals 0. My slope is 0, so I plug in 0. My y-intercept, b, is equal to 0, so I plug that in, and I get y equals 0. Okay, so very quickly, you should be able to identify what your linear equation is if you have both points on the y-axis, or if you have both points on the x-axis. Very simple equation. Things are a little bit different, or quite a bit different, if you have 1 point on the x-axis, 1 point on the y-axis, and 1 point on the x-axis. So how does this look? Well, we see the line that we draw here, it's not vertical and it's not horizontal. So it's very important when you look at the points are 5, 0 and 0, 2, right? X equals 0, y equals 2 for this point, x equals 5, y equals 0 for this point, right? They look similar to the other points that we had, except both x and y in these 2 points are different. In this case here, both y's were 0. In this case over here, both x values were equal to 0. So you need to be able to identify the difference. Just because they're on the axes doesn't mean we have this case or this case. We could have a case like this. If we have a case like this, that's fine. We solve it the same way we solved it in previous videos. We solve for the slope. So y2 minus y1, 2 minus 0. For my numerator, that gives us 2. And x2 minus x1, 0 minus 5. That'll give us negative 5 for my denominator. So I get negative 2 over 5 for my slope. And for the y-intercept, already know it, right? The y-intercept is at this point here, where the point that's on the y-axis. So that's going to be 2. You can solve for it like we did in the previous videos, but why do that? Let's speed through these. And then I have my equation. Y equals negative 2/5 x plus 2. Right? So a very unique situation. When we have 2 points on the axis, we have 3 different possible linear equations that we can get from it.